Hey folks, welcome back to the circulatory system. Today we are going to learn about blood vessels in video number 3. So a couple of types of blood vessels that we need to know. There are sort of some big umbrellas, some big names you need to know, and I think you've heard these names before you even started this course. There are arteries in your body. All of these blood vessels are tubes that carry blood. I probably should have mentioned that off the top. So there's arteries, there's veins, and there's capillaries, which are the big three. There actually are some other blood vessels in between. You can see in this picture there are these things called arterioles and venules. We'll talk about them. They're really just smaller arteries and smaller veins, to be honest. But we're going to look at some of the similarities and differences between these types of blood vessels. And again, they're all over in your body, carrying blood from your heart to your head, to your toes, and back. Capillaries allowing gas exchange. Lots of good stuff going on there. Got to keep all that blood moving. Keep CO2 being removed from your cells and get oxygen to your cells. So all of that blood is traveling through these blood vessels. So let's focus in on arteries for a moment. So their function, a lot of times people say, oh, arteries carry oxygenated blood. But that's actually not entirely true. There's one exception that we talked about in the heart. The best we can say, the only true statement we can make about arteries is that they carry blood away from the heart. So when blood is leaving the heart and going somewhere else, it will travel in an artery. It does carry, or they do carry, oxygenated blood to the body, to like 99% of your body. Arteries are carrying oxygenated blood. But if you think about your heart, and you've gone through that first video and you've done the heart labeling, you'll know that there's one special blood vessel, one special artery that carries deoxygenated blood, and that is the blood vessel that leaves the right ventricle and goes to your lungs. So that one's carrying blood away from the heart, so it's an artery, but it's actually deoxygenated blood because it's on its way to the lungs to become oxygenated. So that's the one exception right here, is the pulmonary artery, which is leaving your heart. Every single other artery, of which there's lots and lots and lots and lots, carries deoxygenated blood. But because there's that one exception, we technically shouldn't say that they carry oxygenated blood. We should just say that they carry blood away from the heart. Arteries, in terms of their structure, they have nice thick walls, and they're very elastic. That is going to help when your left ventricle squeezes, again, ignoring the pulmonary artery, but all the other ones. When your left ventricle gives a nice big squeeze to push that blood throughout your whole body, and that big pulse of blood comes rushing down the artery, the thing is elastic, so it stretches, and then it sort of snaps and squeezes in behind. And that helps squeeze and move the blood along and through the arteries. So that elastic nature keeps the blood flow moving. There you go. The arterial walls, they expand due to the increased pressure when that left ventricle squeezes. And then the walls rebound after each contraction. They sort of snap back to their original diameter, their original shape. And that's what you're feeling. When you feel a pulse like in your neck or in your wrist, you're feeling those little pulses of blood go through, the blood vessel expands, and then what's the opposite of expanding? I don't even know, contracts back to its regular size. One issue that some people run into when they get older is something called arteriosclerosis, which is when the arteries, just with age, they start to harden and they lose that elasticity. You can imagine that it gets a little bit harder for blood to move through your body. Sometimes that can result in increased blood pressure. Your heart then has to start squeezing harder because it's not getting the help of those nice elastic artery walls. It's a little bit like if you've ever seen like rubber tubing or something like that, and it sort of dries out as it gets older and gets brittle. Same thing with arteriosclerosis. So less rebound, there you go, equals higher blood pressure. Arteries, for their location, they are typically deeper in your tissues. So they're not close to the surface of your body, your skin. They're deeper and they're along bones. The reason for that, the big one, is that they're more protected from injury. These are, I'm going to call them high pressure pipes. And if you cut one, you're in major, sort of at major risk of potentially bleeding to death. So we want to keep them further into the body where they're less likely to be severed. And there's also better temperature control. There's less temperature loss if you keep them inside. So there you go, high blood loss if severed. You do not want to sever any kind of artery. They're the kind that, if you've seen like Quentin Tarantino movies, they would like jet blood out, and sometimes they do. You can actually see a person's pulse by looking at blood leaving from a severed artery. It'd be kind of gnarly. Anyway, there's a YouTube video, you can type that in. I'm sure you could just search it on YouTube as well. Be cautious with that one. It could be kind of graphic. I'll leave that up to you. Oh my gosh, I've got a couple in there. If we were in school, we'd be watching those. Maybe it's a good thing we're not. So that's arteries. What about veins? Well, they carry blood back to the heart. It's the only true statement we can make. Usually, they carry deoxygenated blood from the body back to the heart after we've stripped it of its oxygen for cellular respiration. So that's called systemic blood, right, from the body. There is the one exception that does carry oxygenated blood, and that would be coming back to your heart from your lungs. So the pulmonary veins. So that pulmonary circuit is the exception both for arteries and veins. So the pulmonary artery carries oxygenated blood, which means we can't say that they just carry deoxy blood, even though that's true for 99% of veins. They are, some people say, a blood reservoir. Turns out of the blood in your body, of which there's probably about 7-8 liters of it, 70% of it's in your veins. So there's actually more blood in your veins than there is in your arteries. Getting into vein structure. Sorry, pushed the button a little bit quick, but that's okay. They're thinner walled, so they're not as thick, and they're stretchy. So they're not elastic. They don't like snap back really quickly to their original shape. They're just kind of mushy. And I would show you guys, I have lots of veins in my arms, and you can actually feel some of them, and you can feel that they're kind of like mushy. They're kind of stretchy. They don't receive large amounts of blood. They're quite low pressure compared to arteries, so they don't have to have those elastic, snappy walls to snap back into shape. The reason that they're really low pressure is because arteries are high blood pressure, and then that blood is going to go through capillaries, which are really, really, really tiny. And you might know, if you've ever worked with like irrigation or something like that, that if you have water traveling in a big pipe, you can have high pressure. And then if you force it through a small pipe back into a big pipe, you lose a ton of pressure when it goes from the small pipe back into the big pipe. And that's what happens. It goes from arteries, which are high pressure, to capillaries, which are also relatively high pressure. And then when it opens back up into a nice big vein, now it's going to be low pressure. And veins contain valves. And that is going to help prevent backflow due to gravity. So in your arms and your legs especially, all of your veins are going to have these little valves, and it shows here that as it's pushing the blood back up towards your heart, let's say this is in your legs, for example, it keeps the blood flowing in one direction, which is what we want. Gravity's trying to pull that blood back, so these little valves help keep the blood from flowing back down to your feet. That'd be a bad thing. They'd get all swollen, we'd have really inefficient blood flow and oxygen exchange and CO2 exchange. So those valves work great. Again, if we were in class, which I wish we were, I would show you guys some valves. You can actually see them in the veins in my arms. again, because I'm scrawny and veiny. It's kind of gnarly. You can see where they are by squeezing blood out. You might be able to do it in yours. Who knows? Now, those vein valves... Oh, I should add this in, sorry. Getting ahead of myself. How do we keep the blood moving then? It's due to muscle activity. So we actually have, every time we move our legs and our arms, that movement of the muscles and things moving around helps keep blood flowing in the proper direction, back towards the heart. Here's the picture I meant to, or was starting to talk about. When valves fail, sometimes when you get old, especially in your legs, those valves will start to fail. They'll start to let blood leak back through them. That's how we, you, me, might develop varicose veins. And you can see that these big bulges, right? That's blood sneaking through the valves and then just sort of piling up between one valve and another. So you can actually see there would be a valve right there and blood is pooling between that valve and this valve. There'd be one right there and probably another valve right there. And they're leaky and they're letting that blood move back down due to gravity. They're kind of unsightly, to be honest. That's about the only issue. And quite often, to get rid of varicose veins, they'll actually just remove the vein, which is crazy. They'll like snip it here, and actually just strip the thing right out. And then you have enough other veins that they still will carry all the blood back to your heart that you need to get there. So that's kind of crazy. And a treatment for varicose veins is called vein stripping. In terms of their location, we said arteries were really close to bones, deeper in your tissues. Veins are closer to the surface, and they're often surrounded by muscle. And again, we said those muscles help squeeze the blood back to the heart against gravity. And they're lower pressure, so there's less blood loss if they're severed. If you've ever gone and donated blood, they have used the needle to tap into a vein, not an artery. Or if you go to the doctor or a lab and you get your blood taken, they're tapping into veins. Close to the surface, low pressure. You don't have to worry about usually bleeding out if you sever a vein. Although there are some big veins, like your jugular vein in your neck is a big one that has been severed. I've seen it in hockey before. Not in real time, but I've seen videos of hockey players. There's been a few goalies over the years that have had their jugular vein severed. And because that's a big vein in your neck, there's some pretty massive blood loss. It's happened a few times in the NHL, but everybody has survived, again, because they're lower pressure. So you can actually just put pressure on it to sort of stop that bleeding. And then everybody who's had it, knock on wood, every goalie that I've seen or heard of that's had their jugular vein severed, of which there's only a few, they've been just fine. Arterioles and venules are just like smaller versions of arteries and veins. So I had mentioned capillaries are really tiny. Arterioles and venules are just like pipe reducers. So arteries and veins are really big. Capillaries are really tiny. So we've got arterioles to reduce the size of arteries down to the capillaries. And then venules increase the size from the capillaries back to the veins. So same features as arteries, same features as veins, but on a smaller scale. Arterioles have little sphincter muscles, or muscles around them, which can allow them to dilate, which is kind of like expand. Or if that muscle squeezes, it can contract them, which regulates blood pressure and the amount of flow going through those arterioles. And that's what your body is doing with blood temperature regulation. So you might know this. I notice it when I run, especially when it gets warm, that when my body gets hot, it needs to cool down. So what it does is it actually increases the blood flow in a lot of those arterioles and venules near the surface. And then you get that cooling. By exposing them to the environment, that helps cool them down because the environment's usually cooler than the inside of your body. So if I'm really hot, my veins will stand out. Right? I get even veinier. And that's a temperature control thing. And when you get cold, quite often you'll go like pale or white, like it says here, white lips and fingertips. And that's because you're actually reducing blood flow to the surface. You're trying to keep the blood warm. And so you're, allowing the blood flow to be further into the body, just with muscles relaxing and allowing those blood vessels to sink inwards a little bit. And that, again, conserves temperature, keeps things warm, but does make things appear white. Capillaries are the sort of connections between, here it says arteries and veins, but I guess it should technically say connects arterioles and venules, because you do need those little pipe reducers in there. Their function is like gas exchange and fluid exchange. So they're super tiny. They allow water to move back and forth between cells and blood, oxygen to move between cells and blood, and nutrients to move between cells and blood. They pick up water and waste from spaces in between cells, and they actually are like by far the most numerous blood vessel in your body. Here's a couple pictures from that Body Worlds exhibit that we've talked about. This is showing blood vessels in a person's head. You can see if you take away everything other than sort of blood vessels, you can still see what the person looks like, and you can still see what the shark looks like. They look like a foam person or a foam head or a foam shark, just because there's so many blood vessels in our body, so many capillaries. It actually turns out, I think I have it here, yeah, super thin walled, which is required, single layer of cells, that's required for water and gases to exchange efficiently across them. Kind of like alveoli, right? So that allows diffusion of nutrients and gases and wastes, whatever needs to go in or out of the blood. And in terms of their location, they are everywhere. I said they're the most numerous blood vessel by far in your body. This is kind of crazy. Almost every single cell in your body touches a capillary. So you can think about that. If we're like, what was the number? 10 trillion or 20 trillion cells? If every couple of cells is sitting near a capillary, that means you probably have trillions of capillaries as well. So you and I, if you sort of think about our internal structure, a huge amount of our internal structure is just capillaries, because they really do need to service. Basically, every single cell in the body is touching a capillary. There you go. All cells need nutrients and gas exchange, so they all need to be sitting near a capillary. So there is a huge number of capillaries. So that's the blood vessels, just in terms of structure and function. Now I want to name a couple of big ones within the body that you guys should know. So the aorta is the main sort of pipe coming out of the heart. So when your left ventricle squeezes, we've talked about the aorta in the first lesson. Left ventricle squeezes deoxygenated blood that has to go from your head to your toes. It is going to leave the aorta. Coronary arteries and veins, we mentioned in the second video, I believe, they're the ones that actually service the heart. So they're on the surface of the heart, and they are serving the muscles of the heart itself. Because remember, the heart is a muscle, so it's producing CO2 that it needs to get rid of. It needs oxygen and other nutrients for cellular respiration. So coronary arteries and veins are the blood supply to the heart. Arteries supplying things to the heart, and veins removing blood from those heart muscles. They're the ones too. Coronary arteries and veins, they're the ones that can become plugged with those fatty deposits called plaques, and that can cause heart attack. Because some of the muscle tissue, if you block one of the pipes carrying things like oxygen, those little section in here could potentially die, and irregular heartbeat, or it stops beating, that's a heart attack. Serving your head, we've talked about this one too, because it was one of the peripheral chemoreceptors in the respiration unit. You've got your carotid arteries. So these would branch off of your aorta, and they carry blood to your head. Oxygenated blood. Up to your head, up to your eyes, up to your brain. Draining your head, so that carries oxygenated blood up to your head, but now we need to get the deoxygenated blood from your head and your brain back down your body. That is the jugular veins. So they bring blood from the head back to the heart. They would end up tying into the heart through the anterior vena cava. You can see these ones running through the person's neck, and these are those ones I had mentioned, a few goalies in the NHL. If you Google search it, warning, graphic content. Some people have had skates come up and sever their jugular vein, and they're still, you can see the size of these things. They're large. So there's a lot of blood that ends up escaping from them when they're severed. But those are what drain your head back into the heart via the anterior, or sorry, that should say superior vena cava. Let's change that. My bad, just caught it now. To superior. There we go, fix it. Oh, sorry, and my R and I look like an N. My bad. No valves in your jugular veins, and if you think about this one, you want the deoxygenated blood going back to the heart. You want gravity's help. So gravity is going to help pull things down, so you don't want valves preventing that. So remember we mentioned valves are in veins. Well, that's typically only veins that are below your heart, because that's where gravity pulling things down is an issue. Here we want gravity to pull that blood back to the heart. That's doing the job for us, so we don't want to have any valves there. Your subclavian arteries and veins. Clavicle is your collarbone. It's the medical term for collarbone. So subclavian means under your collarbone. So that's where these things run. So subclavian arteries and veins are the ones that feed your arms and your chest. So sort of your torso and then into your arms. Arteries would carry oxygenated blood to your arms and torso. And the subclavian veins would bring deoxygenated blood from your arms and torso back to your heart. Now we get into some in the digestive system. So we've already talked about the digestive system, and we talked about how there's a big blood supply there. All those little villi and microvilli have blood supply. So there's a couple in here that service all the different parts of your digestive system. So the mesenteric artery and vein are the ones that serve your, do I even have the things in here? Yeah, sorry, there it is, weird order. Mesenteric artery and vein are what service your intestines. So hopefully you're looking at that going, ooh, those ones are important, because the mesenteric arteries and veins are the ones that are getting all the nutrients from digestion. So those are really, really important. The hepatic portal vein is the pipe that carries nutrients from the intestine to the liver. So remember things like sugar, glucose. It's really important that that goes to the liver and is stored in the liver with the help of insulin. So the blood that is going from your intestine, it goes straight to your liver. That's the first stop after your intestine. That's called the hepatic portal vein. Anytime you see that hepatic, we're talking liver. So the hepatic portal vein goes from the intestine to the liver, and then the hepatic vein, take out the portal piece, that is blood going from your liver back up to your heart. So mesenteric is intestines, hepatic portal is intestines to liver, and hepatic vein is liver back to your heart. And it goes via the inferior vena cava, the lower half of the vena cava. We're getting close. What about your kidneys? Kidneys is renal. So anytime you see renal, that means you're talking about your kidneys. So renal arteries and veins are the ones bringing deoxygenated blood to your kidneys or away from your kidneys. And again, we'll look at kidneys towards the end of the course. They're the ones that are responsible for filtering your blood and creating urine. Very, very important to get those wastes out. Iliac arteries and veins. So that's an I. There you go. I-L-I-A-C. Iliac arteries and veins are the blood vessels servicing your legs, your lower extremities. So they run sort of through your groin region. And we talked about how arteries stay close to bones. So your iliac arteries would be ones that run right along your femur, right? Nice and deep and protected in there because they're big blood vessels as well. Iliac veins would carry blood from your legs back up to your heart. So there you go. There's a little femoral artery too, which branches off from the iliac artery. And I think this might be the last one, your superior and inferior vena cava. We already talked about these. The big pipes going right back into the right atrium. So it collects all the blood from the veins of the systemic circuit and pulls it back to the right atrium. Remember, the top half is the superior vena cava, that's draining the upper part of your body into the right ventricle, right atrium. And then the inferior vena cava is carrying all the blood from the lower half of your body back into the right atrium. Oh, sorry, not quite the last one. Hopefully this is the last one. Pulmonary arteries and veins. We know this one. Pulmonary means lungs. So that's the pulmonary circuit, we call it, because it's kind of going in a circle. You can see these one-way streets. Remember, this is the exception with the artery. The artery here is actually carrying deoxygenated blood, while the pulmonary vein is carrying oxygenated blood. So the opposite of all the other arteries and veins in your body. The exceptions to the rule. So here's what you need to know. Arteries versus veins versus capillaries in terms of sort of their structure and their function and where we find them. And then all of those major blood vessels in your body. Know their names and know their general location anyway. If you have any questions about this information, please let me know. Send me an email or join me for Zoom. Actually, you know what? Even if you don't have questions, come say hi in a Zoom session. It'd be great to touch base with you. You can keep plugging away at the circulation assignment. We'll have some questions on this stuff. And there will also be in the homework assignments section at the bottom of the webpage a diagram for you to label with the names and locations of those major blood vessels. So give that a try and come and say hi in Zoom. Have fun, folks.